In the vastness of the cosmos, a single question has captivated humanity for centuries. Are we alone? Among the countless celestial bodies scattered across the universe, one planet has long stood out as a beacon of possibility: Mars, the red planet. Its rusty hue, visible even to the naked eye, has inspired myths, stories, and scientific inquiry for generations. Today, we embark on a journey to explore a question that lies at the heart of our curiosity about the universe. Is there life on Mars? Through decades of exploration, scientific discovery, and relentless pursuit of truth, we will uncover what we know, what we suspect, and what remains beyond our grasp. Mars, the fourth planet from the Sun, has long held a special place in the human imagination. Named after the Roman god of war, its reddish appearance, caused by iron oxide or rust on its surface, has made it a symbol of mystery and intrigue. To the ancient Greeks, it was Ares, the god of war, streaking across the night sky. To early astronomers, it was a world of canals and civilizations, imagined through the blurry lenses of primitive telescopes. To modern scientists, it is a frozen desert, a planetary laboratory that holds clues to the possibility of life beyond Earth. But what makes Mars so compelling? Why do we look to this distant world with such hope and fascination? The answer lies in Mars's striking similarities to Earth. Though smaller, about half the diameter of our planet, Mars has a day length nearly identical to Earth's at 24.6 hours. Its axial tilt gives it seasons, much like our own, though they last twice as long. Its surface, scarred with vast canyons, towering volcanoes, and dry riverbeds, hints at a dynamic past, one where water, the cornerstone of life as we know it, once flowed in abundance. These features have fueled speculation about whether Mars could have once harbored life or if it might still. Our journey begins with the history of Mars exploration, a saga that spans centuries and reflects humanity's unyielding desire to understand the cosmos. Early observations of Mars were limited to what could be seen through telescopes. In the late 19th century, Italian astronomer Giovanni Schiaparelli reported seeing canali, in Italian for channels, on the Martian surface. Misinterpreted as canals, these observations sparked wild speculation about intelligent life and engineered waterways. American astronomer Percival Lowell further popularized this idea, claiming to see a network of canals built by a Martian civilization. Though these claims were later debunked, they ignited public fascination with Mars and set the stage for scientific exploration. The dawn of the space age brought new tools to probe the red planet. In 1965, NASA's Mariner 4 became the first spacecraft to capture close-up images of Mars, revealing a barren, cratered landscape that shattered dreams of lush Martian civilizations. Yet, these images also raised new questions. The surface showed signs of geological activity, features that suggested a more complex history than a lifeless rock. Subsequent missions, like Mariner 9 in 1971, revealed towering volcanoes like Olympus Mons, the largest in the solar system, and Valles Marineris, a canyon system that dwarfs Earth's Grand Canyon. These discoveries painted a picture of a planet that was once geologically active, perhaps even hospitable.
The search for life on Mars hinges on one critical ingredient: water. On Earth, wherever there is liquid water, there is life, from the depths of the oceans to the harshest deserts. Mars today is a cold, arid world, with surface temperatures averaging -80 degrees Fahrenheit, (-62 degrees Celsius), and an atmosphere too thin to support liquid water for long. But evidence suggests that Mars was not always so inhospitable. In the 1970s, NASA's Viking program provided the first direct search for life on Mars. The Viking landers, equipped with experiments to detect microbial metabolism, scooped up Martian soil and tested it for signs of biological activity. The results were tantalizing but inconclusive. One experiment, the labeled release experiment, detected what appeared to be metabolic activity, but other tests failed to confirm the presence of organic compounds, leaving scientists divided. Was it life or simply exotic chemistry? Decades later, NASA's Mars exploration rovers, Spirit and Opportunity, launched in 2003, provided compelling evidence that liquid water once existed on Mars. Opportunity discovered hematite, a mineral often formed in water, and both rovers found geological formations consistent with ancient riverbeds and lakebeds. The rover Curiosity, landing in 2012, took these findings further. Exploring Gale Crater, a site believed to have once been a lake, Curiosity detected clay minerals and other signs of prolonged water activity. Most astonishingly, it found organic molecules, carbon-based compounds that are the building blocks of life. While these molecules can form through non-biological processes, their presence raised the possibility that Mars could have once supported microbial life. But what about water today? While Mars's surface is dry, evidence of water persists. In 2006, NASA's Mars Global Surveyor detected changes in gullies that suggested recent flows of liquid water, possibly from subsurface reservoirs. In 2018, the European Space Agency's Mars Express mission identified a potential lake of liquid water beneath the planet's south pole, buried under layers of ice and dust. This subglacial lake, detected using radar, is rich in salts that lower the freezing point of water, allowing it to remain liquid in Mars's frigid conditions. Such environments on Earth, like Antarctica's subglacial lakes, teem with microbial life, raising hopes that similar ecosystems might exist on Mars. The search for life extends beyond water to the Martian atmosphere. In 2003, scientists detected traces of methane in Mars's atmosphere, a discovery that sparked excitement. On Earth, methane is often produced by living organisms, though it can also come from geological processes like volcanic activity. Mars's methane levels fluctuate, with seasonal peaks that defy easy explanation. Curiosity has since confirmed these methane spikes, particularly in Gale Crater. Could this be a sign of microbial life releasing methane as a byproduct? Or is it the result of abiotic processes, such as chemical reactions in the Martian crust? The debate continues, but each new measurement brings us closer to an answer. To understand Mars's potential for life, we must consider its history. Billions of years ago, during the Noachian period, Mars was a very different world. Evidence suggests it had a thicker atmosphere, warmer temperatures, and liquid water flowing across its surface. Ancient river valleys, lake beds, and deltas, visible in satellite images, point to a planet that could have been habitable. Some scientists hypothesize that Mars may have been more Earth-like during this time, with conditions suitable for microbial life. But something changed. Mars lost its magnetic field, leaving its atmosphere vulnerable to solar wind. Over time, the atmosphere thinned and the planet cooled, locking much of its water into polar ice caps or subsurface reservoirs. If life once existed, could it have survived this transformation? The question of life on Mars is not just about the past, but also the present. Extremophiles, organisms that thrive in Earth's harshest environments, offer clues about what life on Mars might look like. In Earth's Atacama Desert, one of the driest places on the planet, microbes survive in salty soils, drawing moisture from the air. In Antarctica's dry valleys, bacteria live within rocks, protected from the harsh environment. These analogs suggest that Martian life, if it exists, could be microscopic, hardy, and hidden, perhaps in subsurface brines or deep within the planet's crust. NASA's Perseverance rover, which landed in 2021, is searching for such signs in Jezero Crater, a site once home to a river delta. Perseverance is collecting rock and soil samples, which will be returned to Earth by future missions for detailed analysis. These samples could hold the key to detecting ancient life. Yet the search for life on Mars is not without challenges. The planet's surface is hostile, bathed in ultraviolet radiation and cosmic rays due to its thin atmosphere and lack of a magnetic field. Any life on the surface would need to be extraordinarily resilient. Subsurface environments, shielded from radiation, are more promising, but accessing them requires drilling capabilities beyond our current technology. Contamination is another concern. Earthly microbes, carried by spacecraft, could interfere with experiments or even colonize Mars, complicating the search for indigenous life. NASA and other space agencies follow strict planetary protection protocols to minimize this risk, but the challenge remains. Looking to the future, new missions promise to deepen our understanding. The European Space Agency's ExoMars rover, set to drill deeper into Mars's surface than ever before, aims to search for biosignatures in regions untouched by surface radiation. China's Tianwen-1 mission, with its rover Zhurong, is exploring Mars's southern hemisphere, adding to the global effort. Meanwhile, private companies like SpaceX are eyeing Mars not just for science, but for human exploration. Elon Musk's vision of a Martian colony raises questions about how human presence might affect the search for indigenous life. Could our footsteps erase the very evidence we seek? As we ponder the question of life on Mars, we must also consider its broader implications. Finding even microbial life would revolutionize our understanding of biology and our place in the universe. It would suggest that life is not unique to Earth, that the cosmos may be teeming with living worlds. Conversely, if Mars proves lifeless, it could underscore the rarity and fragility of life, urging us to protect our own planet. Either way, the search for life on Mars is a mirror reflecting our deepest questions about existence, resilience, and the future of humanity. Our journey to Mars is far from over. Each mission, each discovery, brings us closer to answering the question that has haunted us for centuries. Is there life on Mars? For now, the answer remains elusive, hidden in the red sands, the icy subsurface, or the faint traces of methane in the air. But with every rover that roams, every sample collected, and every image beamed back to Earth, we edge closer to the truth. The red planet holds its secrets tightly, but humanity's curiosity is relentless. In the silence of the Martian landscape, we listen, we search, and we dream of life, of answers, and of a universe that might one day call us home.